Equation building. Can we do it? Yes, we can. All right. It's about a dude and his truck going down a bridge, and we don't want to break that bad boy. That's what this one's about. So we need to make sure that we don't carry too much stuff. And the question is then, how much stuff can we technically put onto this truck? This is going to be done by creating a linear equation and then isolating the variable. So let's start breaking down the different parts here. We know that the weight limit is 6,000 pounds. And then a delivery truck that is carrying X identical boxes, each weighing 14 pounds, is going to be on that truck crossing the bridge. If the weight of the empty delivery truck and its driver is 4,500 pounds, so the dude and the truck itself, when there's nothing in it, is 4,500 pounds, how many boxes can you bring without breaking the bridge? Well, how does this work out? Well, we know that our limit is 6,000. And really, this is the most important thing here to practice, and that is asking, will the rest of the expression be less than or greater than that? Well, because we don't want it to be over 6,000, we really want 6,000 to be the biggest number that we see. So that's why we want 6,000 to be greater than or equal to the rest of the equation, or relatively speaking, the rest of the equation to be less than or equal to 6,000. So that's why we're going to keep that sign there. We know that it's X identical boxes, each weighing, key word here, because we know that that means that we are dealing with a rate. So that means we want to see something times something else. So that's why it's going to be 14x. And we're now going to be adding that to what the truck and the driver already weigh, which is 4,500. And now all we got to do at this point is get x by itself. We can do that by first subtracting 4,500 to both sides, minus 4,500. You subtract that, and then we will end up with, what, 1,500? And then now we have 14x is equal to 1,500. And if we divide that, 1,500 divided by 1,4, you end up with 107x equals 107.14. Always interesting answer when we're dealing with a situation where we're dealing with boxes, so we can't actually have decimals here. We want to recognize that what's the total number of whole boxes. So we want to because we don't want to go over our weight, we need to stay at the first integer that we round down to, which is x equals 107. So even if let's say pretend that the answer was 1.07, like 0.9, you still want to say the answer is 107, because if you brought it to 108, you would realize that and you plug that back into this equation, you would realize that you're over 6,000 pounds. So it's not about rounding, it's about finding what number makes sense for the situation described.